Hello everyone, welcome to another Python tutorial series. So collision is a big part in game development. So in this video, I'm going to simulate collisions. And this is another episode of physics in a Python video, and I hope you like it. So first of all, let's import our modules and create a Pygame window. So import Pygame, Pymunk, not math. And we also want to import randint from the random module, so randint. Then we want to set pygame.init. We'll create our window, so pygame.display.setMode. We'll have our window 600 by 600 pixels. We'll set our clock equal to pygame.time.clock. And now to create our window, or to run our window, we'll have a variable called running equal to true. And we'll have a while running loop or event in pygame.event.get. We want to check if event.type is equal to pygame.quit. Then we'll set running equal to false. And now we can have pygame.display.flip. And lastly, when the while loop is stopped running, we can quit out of Pygame. And so if I run this, we should see a black window, which we do. So now let's just define some constants up here that we'll be using for the simulation. We'll have an FPS equal to 50, a white variable equal to 255, 255, 255, and a black equal to 0, 0, 0. So now I can set the window color to white. And so I will do that in this while loop. So I'll set window.fill with the white color. And lastly, I'll set clock.tick at the FPS variable that I created earlier. So now if I run this, you see that the window is now white. So now let's create a Pymunk space. As we talked about in my previous video, Pymunk space is a basic unit of simulation. And so you add bodies, shapes, and constraints to a space, and then update the space as a whole. They control how all the other rigid bodies, shapes, and constraints interact with each other. So what I'll do is create a Pymunk space, and I'll have it equal to space variable. So pymunk.space. And we also want to update the simulation with the step function. So what I'll do is write space.step 1 over FPS. And so now let's create our objects that will interact under physics. So in this video, the objects are going to be balls with different sizes, and hence different masses. So because we're going to create a lot of balls, we can create a class for them first. So what I'll do is create a ball class. So class ball. I'll define init of self, x, y, and size. I'll set self.size equal to size. I'll set mass equal to self.size to the power of 2. And set the color equal to randint from 0 to 255. Randint 0 to 255. Randint 0 to 255. So this will randomly choose a color for the ball. I'll set the angle equal to random int from 0 to 359 degrees. And I'll set the coefficient to 40,000 over the mass. And then additionally, what I'll do is set the self.body equal to pymunk.body mass. And I'll set the body position equal to the XY position that's given to us as a parameter. And then I can set self.body.velocity equal to the coefficient multiplied by math.cosine angle times math.pi over 180, and the coefficient times math.sine of the angle times math.py over 180. And so by including the coefficient right here, we assume that each ball, regardless of its size, has the same momentum initially. So I'll set this shape as well. So self.shape equal to Pymunk.circle self.body and self.size. I'll set self.shape.elasticity is equal to 1 and self.shape.density equal to 1. And then I'll add this to the space that we created above. So space.head, self.body, and self.shape. And I want to note that this elasticity value determines how bouncy the ball or the body is, and a value of 1 means a perfect bounce. And here we're creating our circle ball. So we also need to define a draw method to draw and visualize the objects created in Pygame. So right here, I'll define a draw method of self. Set x equal to int self.body, and then position or self.body dot position dot x. Let's set the y equal to int self.body dot position dot y, and I will draw the circle onto Pygame. So window self.color xy and self.size. So now let's create some ball objects and show them in Pygame. So I can create a balls list of ball. I'll pass in a parameter, so 0 to 600, rand int. I use rand int again, from 0 to 600, rand int 10 to 20, for I in range 20. So essentially, I'm going to be creating 20 balls, each with a random size, velocity, and color. And then they'll be able to collide with each other and eventually go out the window. So once I've created this list, now when I'm in the while loop, I'll go through each ball and then I'll draw them onto the window. So ball.draw for ball and balls. So if I save and run this, if we look at this, we have body has no object. Body object has no attribute position, so there's a misspelling. If I go back, all I need to do is change this to position. And if I save and run this again, now we have a few balls colliding with each other. So instead of letting the balls go out the window and disappear, we want them to stay in the box at all time. So we need to block them when they reach a boundary. So how do we do that? What we need to do is create some static bodies and put them around the boundary. And because we need multiple, in this case 4 static bodies, we'll define a function for it. So then what we could do is define create segment of position 1 and position 2. And so position 1 and 2 are the positions of the starting and ending points of the segment. We'll set segment body equal to Pymunk dot body. We'll set the body type equal to Pymunk dot body dot static, and the segment dot shape or segment shape will be equal to Pymunk dot segment with the segment body position 1, position 2, 10, and so 10 is going to be the width of the segment. Segment shape dot elasticity is equal to 1, and then I'll add this to the space. So the segment body with a segment shape. So I'm adding the body and shape to the Pymunk space. So now we'll create our 4 segments as the 4 borders right here. So I have position T1 to 0, 0, position TR, and actually this should be not T1. I'll change TL, which will represent the left side, TR, which will represent the right side, so 600, 0, position BL, which is the bottom left, equal to 0, 600, and TL and TR, they both represent top left and top right. Position bottom right will be equal to 600, 600. So to create our 4 segments, I'll have segment 1 equal to create segment, position T1, or not T1, TL, and position TR. So that's one segment. What I'm going to do is copy this and create the other 3 segments. So this will be TR, and this would be bottom right, this would be bottom left, and this would be bottom right, this would be bottom left, and this would be top left. And then I'll change this segment 2. Let's see, segment 2, 3, and 4. So now we just need to draw our segments. And so underneath the balls, I'll call pygame.draw.line, window, black, position of TL, position of TR, and 10. So if I copy this, paste it 3 other times, I'll change this to position of top right. This would be bottom right, this would be bottom left. Now this one will be bottom right, bottom left, and top left. So now if I save and run this, now you see that our balls are enclosed in this box so they don't leave our window. Notice that some of them are a little faster than others because some of them have a greater velocity, but they all have the same momentum. So larger balls move at a slower speed and smaller balls move at a greater speed. But after collisions with each other, things start to change as momentum is transferred from one another. Now we can also change the number of balls in the simulation. For example, we have 50 balls instead of 20, and to do that, all I have to do is change this loop to 50. So if I run it again, now I have a lot more balls in the simulation. So this is the end of this video. If you have any comments, please put them below at the comment section. If you have not subscribed to the channel, please hit the subscribe button below. Thank you for watching, and I'll see you guys next time.